set of lines in bus? Yes. Can you answer quickly? What is bus? Bus is used for connecting all peripheral devices. So how you can classify the lines that is present in the bus? What are the three categories? Data bus, address bus and control bus. Okay. So those are all the basic things you already learned. Okay. Yes. Stop your discussion. Okay. So processor, main memory, IO devices are interconnected by common bus, and whatever we are discussing till now, we are just considering single bus. Okay. We are not discussing about the multi bus. Okay. So whatever we are discussing, it is single bus. Next. Bus provides communication path for transferring the data. Okay. Whatever the, either it may be program or it may be the data required by the program, everything to transfer from main memory to the processor, it has to go through the bus. Okay. So about bus accessing we have discussed. Now we'll look into this bus, how data transmission takes place in terms of timing diagram. So what is bus here actually? Okay, so bus is a protocol. Protocol is nothing but set of rules. They have defined set of rules to be followed to transmit the data on the bus. Okay, so it has to follow those rules for transmission of data between processor and main memory. So this is already familiar. That is how you can classify the bus. Means you can see here just one line, but inside that you will be having set of lines. Okay. Once again, those set of lines are divided into some lines. It is going to carry the data. Okay. Address. Okay. Address of the device, or it may be address of the memory, and control signal. So what type of operation it has to perform? Is it read operation or write operation? So that control signals are sent through control lines. Not only read and write, we have discussed in interrupt to carry the interrupt signal. Okay, so it requires control signal should be transferred, used. Okay, so control signal specifies what type of operation, is it read or write operation. Okay, and also it is going to specify the size of the data. So control information, even it includes what is the size of data to transfer. Okay, so that is specified in terms of bytes. So now we are going to discuss mainly two types of buses. Okay, whatever you told here, this is the lines are divided into three categories. So with respect to timing information, the bus can be analyzed using synchronous bus and asynchronous bus. Okay, the first one is synchronous bus. So what is the difference between synchronous and asynchronous? We'll discuss. So yesterday I was explaining. So any operation in the computer system. Any doubts? Okay, any operation in the system, it is going to take place according to the clock information. Yes, no, yesterday I told. So for every clock tick, there is some operation is going to take place. So now how to represent that clock information? Okay, for that you are going to take the clock information where there is one positive cycle and one negative cycle. We call it as a bus cycle. So within this duration from here to here, okay, it is going to perform a particular operation, either read or write, transmission of some information. It is going to take place within this clock cycle. Whenever if any operation to be performed, it is not like that it requires only one bus cycle. It may require more than one bus cycle to transmit the complete data. Okay. So now what is the speciality in synchronous bus? What is the speciality in synchronous bus? Always when I use the term synchronous bus, you need to remember that there is a common clock. Common clock used. Okay. What is the meaning of common clock? So for all the devices, it is going to refer only one time information. Okay. So either processor, memory, IO devices, it is connected. It is going to refer only one common clock information. So accordingly, it is going to perform the operation. Is it clear how to represent the clock cycle? So one negative and one positive. Okay, or you can just take positive first and negative. So this we call it as one clock cycle. So like this there will be n number of clock cycles to complete the operation, and also this duration whatever you are going to specify now, this is called time interval, and this should be same for all the clock cycle. You cannot write like this is one clock cycle, okay, and this is another clock cycle. No, so always the clock cycle time interval, it is going to be fixed. So whatever the length it is taken by this clock cycle, same thing should be followed for the next interval of time. This is time t0 and this is t1. When you are drawing the diagram, just be careful about the clock length. Okay. Now you need to draw the diagram. Just observe. Just observe here. There is a bus clock. We already know that there is a positive cycle and negative cycle. Okay, and this duration indicates the time information. Okay, so now whenever if it requires to perform the read operation, okay, we are going to discuss this bus with respect to read or write operation. Whenever if it want to read the data, means it is going to get the data from keyboard, okay, or somewhere with some other input devices. So in that case, if processor want to read the data from input device, what are the information it has to send? It has to send the address to which device, okay, to which device it is addressing, and also it is going to send the command, okay, indicating what type of operation. I told, is it read, write, and also the command indicates how much of data it has to transfer, that is size of data. Are you able to understand? So first understand the key terms. Address indicates the address of the device, to which device the processor is going to request the data. Okay, and command indicates, so is it read operation? If it is read, always the signal level is 1, and if it is write, it is going to be 0. Okay, so can you see here? First you need to draw the diagram like this. Okay, just write the clock information, then you have to, you can just observe address and command information, it is sent together here. Okay, just indicating that address and command information, it is placed on the respective line at the same time. So that is the reason why you are getting the intersection. But you can see this blue color line indicates it is carrying the address information, and this black color line indicates it is carrying the command information. What do you mean by command? Read or write and the size of data it has to transfer. Okay, when I tell the command, you should be knowing that what type of operation and what is the size of data it want to transfer. Okay, so now it is going to place, now processor is going to consider it is requesting data from input device. It is going to, so always in the exam you may get explain synchronous input operation, okay, or you may get explain synchronous read operation, both are same. Okay, so now whenever processor want to read some data from the input device, it is going to place the address indicating to which device it is going to request the data and what type of operation. Okay, it is going to place the data on the respective line. Now, so whichever the device that is matching with the address, okay, which are all connected to the bus, it is going to receive the address that is sent by the processor. What happens next? We have discussed in the beginning of this chapter, in the IO interface there is an address decoder. Okay, so that address decoder, it is going to match, is that address is matching with this device or this device. Whichever the device that matches with the address, that will get recognized. Okay, and it is going to check what is the command information it is sent by the processor, and it will respond to that and it will transfer the data. You can just observe here at time t0, okay, master. Okay, so here there are two terms you need to understand. One is master and another one is slave. Whichever the device that is going to request some data transmission, okay, so that we call it as master device. Whichever the device that is responding to the request, that we call it as slave. Okay, now at time t0, master places the device address command on the bus and indicate it is a read operation. Okay, through the command information it is going to tell it is a read operation. Now at time t1, what happened? So at time t1, that means you need to understand what happened between time interval t0 to t1. Okay, t0 to t1, it is called as propagation delay. Okay, whatever the data, I mean address and command it is placed on the line, it will take some amount of time to reach that particular device. Okay, first it has to come on the bus, then there is an interface, then DMA controller, then IO device. Okay, so it will take some amount of time. So that time we call it as propagation delay. So that propagation delay it is denoted with T0 to T1. So it should be like whichever the device that takes maximum more propagation delay. So that should be the value you need to set between T0 to T1. Okay, then after T0 to T1, you can just see, so whichever the device that is addressed, so that is going to recognize. Okay, I told address comes now, consider if it is matching with this device, so it is going to place the requested data on the bus. Okay, how it is going to represent it, can you see here? So it is not performed anything here. So this data, whatever I have just represented, what is this notation? You can just write it like bits 0 and 1 like this. Instead of that, they have used either the data may be positive, or positive means it is 1, or it may be 0 to indicate that they have used this pattern. Okay, so if it is 1, the signal will be represented like this. If it is 0, this is the signal. So just to denote either it is 0 or 1 placed on the bus, so they have used this pattern. Okay, by time t2, okay, the requested data is placed on the bus. Okay, this device is placed on the bus and processor is going to strobe that data. Strobe means it is going to capture the data and it will store into its buffer. So now can you explain what are the changes it requires for output operation or write operation? Quickly. So what are the changes it requires with respect to this diagram? Write means consider now processor want to write the data onto the output device, either display or it may be the printer. So what and all it is going to do? How it is going to initiate the operation? It requires address, okay, to which device it is going to make the request, that address it is required, command information is required. Along with these two, even it requires the data, what data it want to write onto that particular output device. Okay, it has to place the data also. Okay, that is for output operation. That diagram is not there in the textbook. You should understand these are the modification you have to do it. Clear? Let me see quickly, write this diagram. Yes, I won't give much time. So you need to draw quickly. And output, you write it later. Just write the heading later, synchronous output operation or write operation. Now you just write for input and read. So just write the diagram. So all this explanation you can just get it from the notebook. Okay, just write the diagram. Now you can ask how they have fixed the time, that is T0 to T2. It indicates one read operation. So how they are going to decide the how much time it is required for read operation. Okay, always the time is obtained because we are, I told it is going to use common clock. Okay, so because of that, whichever the device that is working at slowest speed, maybe the printer works faster, keyboard works slower. In that case, whichever the device that are connected to the bus that is having slowest speed, accordingly the time interval is set. Okay. Finished? Okay. Yes. Can you quickly observe the diagram? Is it similar to the previous one? Just observe, don't write. Is it similar to the previous one? So what are the changes you can see? There is some delay. Okay. So as soon as the data or information it is sent by the processor, it is not received at the same time at the slave. So the processor is a master. Okay. So as soon as it places address and command, it is not able to see the information by the slave at the same time. There will be some delay. That is once again a propagation delay. Can you see here? Yes. So this block diagram contains two parts. Okay, so this part it is seen by the master and this is seen by the slave. So now you can just observe master sent the address and command information at time interval TAM. Okay, address information sent by the master, but you can just see there is a delay, it reaches the slave. Can you see? This is time interval and when it is reached at the slave. Okay, so that means you need to understand that whatever the information it is transmitting in the circuit, okay, to reach the specified destination, it will take required amount of delay. That comes under once again propagation delay. Okay. Now after that, when the request comes to the slave is going to respond by placing the requested data on the data bus. It is place the data on the data bus at TDS. Okay, and you can see the master is seeing that data at time TDM. That means once again there is a delay when it is sent and when it is received. So there isn't a delay, that is with respect to propagation delay. Okay, so this is the diagram similar to the previous one. Only thing is they have specified the delays that occurs in the circuit diagram. Okay. So now there is one more small diagram similar to that. What is this diagram test? Can you observe? Same operation. What are the difference you can see? It is once again read operation only or input operation. What you can see? Clock is fast. Okay. Okay, good observation. So here, that means in the previous diagram, we have taken only one cycle to perform any operation. But here, depending on depending on the instruction or the program, so each statement may take different number of clock cycles. Example. So example, I can take addition of two numbers. Okay. So now tell me which instruction is get executed faster. Which instruction is going to get executed faster? Yes, first one or second one? Second one. First one. Execute faster. This is slow. Why? Yes. Okay. Here it does not require any memory access. So all the values operands are available in registers, but here memory access is required. That means each instruction may take different clock cycles. Okay. For that reason, we cannot set like only one clock cycle for all the operation. If that is the thing, what happens? So the speed, even though if there are devices that works faster, you are making that device also works at slower speed. Okay, because of that you are going to represent the same operation in multiple clock cycles. Okay, can you see This is one clock cycle. This is second, third, fourth. So now in the beginning first clock cycle, the master is going to place the address and command information, and it is requesting for the slave to send the requested data. Okay. And also in the previous diagram, we have not indicated like is it the slave is responded to the request or not. Okay. So one more additional in this diagram is, so here it is going to represent the slave is going to represent the data is placed or not. Okay. So as soon as it places the data on the data bus, immediately it is going to send in a signal called slave ready. Okay. So it is going to send the signal called slave ready. That means the requested data is placed on the data lines. Okay. Then immediately the master is going to strobe. What is the meaning of strobe? It is going to capture the value or the information that is present on the bus. How long it should be there on the bus? It is not like that the data is just moving. Okay, there is some specific time the data should be available on the data bus. Okay, so that the respective device should be able to capture the data. So that is about the synchronous bus. Okay, can you learn by yourself asynchronous bus? I will tell the difference. Here we are not going to use common clock. There is no clock information. Yes, it is not going to use any clock information to perform the operation. Instead of that, it is going to use the protocol called handshake protocol. Okay, so we'll discuss this part in the next class. Whose class next are? Okay.